My name is Bas Arens. I'm an aeolian geomorphologist and a freelance researcher. I work mostly for dune managers and policymakers. My co-talkers, Caroline, Sjouki, and Chris, are all from HKV, and that's a medium-scale company working mostly on flood risk management and nature-based solutions. So why are we, and I say we as the Dutch in general, but I suppose all of you are also fond of notches. Why are we so fond of notches? Well, as a geomorphologist, it's a very spectacular landscape. The geomorphology changes rapidly. You can view changes in the order of a day, and the processes act very vigorously. But probably for dune managers, a more important reason is that notches can provide sediment to the dunes behind the foredunes. And this benefits ecology. For example, burial by a thick layer of sand kills climax vegetation. It makes room for pioneer species, and it also improves the conditions for important habitat types like the white and the gray dunes. And secondly, the input of sand is also important for increasing the dune volume. So the dunes can keep in pace with sea level rise. So notches can be an important means to adapt to sea level rise. Well, we talk about 30 years of notches. About 30 years ago in the Netherlands, there was an important change in coastal management. Until then, the coast was pretty dull, at least the foredunes. The foredunes more resembled like a sand dike. And management aimed at fixating all the sand in the dunes. So the foredunes were intensively managed and there were no blowouts at all. But then there was a change in the coastal policy. And by means of sand nourishments, the Dutch could stop the coastal erosion and keep the coastline of 1990 at its position. So erosion was stopped and therefore there was little need for the intensive management of the foredunes. And well, this means that there came room for natural processes, that wind erosion control stopped, or at least was less. So blowouts could be formed, and they did at a number of places. And some of these blowouts evolved into notches. And around 1997, so about 7 years after this change in coastal management, the first notches appeared. So that's almost 30 years ago. I give a definition of notches, at least in my opinion, as compared to blowouts. On the left, you see a blowout. It's completely closed off by a rim. And on the right, you see a notch. And an important difference between the blowout and the notch is the entrance from the beach. There's a break through upwind. So in the notch, there's a connection with the beach, while in the blowout there is no connection with the beach. But there is also a breakthrough at the other side, at the landward side. Here you see the closed rim of the blowout, but when the blowout develops into a notch, this is also broken, and then the amount of sand that can be transported landward becomes much larger. But I think the main difference between blowouts and notches is that in notches, you have a transfer from sand from beach to the dunes. So the volume of the dunes can increase. While in the blowouts, there's only a redistribution of foredune sand. So there's no further input of sand from the beach. Now, just I show you a small video of the development of notches on the island of Terschelling in the north. They start as very small blowouts here and here, and just watch what's happening. So this is a very spectacular development within only 28 years. Now I'll show you some results of our research on notches. We measured and we draw axes through the notch, and these are the axes of all the same notch from 1996 to 2023. And the green lines are the starting point, so there the notch is still small, and from yellow to orange, the axes are from the present situation. And what you can see is a pattern, and often notches follow the same kind of pattern. The axis shift to the north. This is more or less with the wind direction, because the wind direction along the coast in the Netherlands is with the dominant wind from the southwest. And the length of the axis increases in time, and sometimes also the axis splits up to make a multi-depositional lobe. Well, the same counts for the surface of the notch from 96 green to blue in 2023. And it's a bit difficult to see, but I show a different graph later on. The surface is increasing, and the distance that the sand comes is increasing as well. So the depositional lobe extends over a very large surface at the end. I show some dimensions of typical notches. This is the growth of the length of the axis for a notch on Terschelling, one from the video, and a notch in Noord-Hollands Duinreservaat in the center of the mainland coast. And you can see a clear exponential increase, and the growth is very smooth. R squared is very high in both occasions. The middle one is a different situation. It's a notch on the island of Texel, and this one is stabilizing because in front of the notch an embryonic dune field is growing, and it starts to grow around 2014. And during the growth, the activity in the notch declined. So this is about the length, and the right graphs are about the surface. And we split the surface in the erosive surface, mostly near the opening of the notch, and the depositional lobe at the back, at the landward side. And also these growth rates show very gradual pattern. And the surface area of the erosive zone has a much more smoother growth rate than the depositional zone. The variability in the depositional zone is much larger than in the erosion zone. So for both Terschelling and Noord-Hollands Duinreservaat, notches are also their surfaces are increasing exponential. And on the one on Texel that's stabilizing, it's funny to see that it's mostly the depositional lobe that is declining in area, while the erosion zone is more or less constant the last 2 years. But probably in a couple of years, it will also start to decline, and I think the notch will be completely stabilized and overgrown by vegetation. Just to show the variability of the length of a number of notches, around 60 we examined, and the length varies from about 50 meters, very short notch, to more than 500 meters, which is quite a long length. And the variation of the surface area, it's good to note that the erosion surface is almost always smaller than the depositional surface. And here the variability ranges from about half an hectare for a small notch in the Noord-Hollands Duinreservaat to more than 4 hectares in the big notch of Terschelling, the one that you saw in the video. So that's quite a large surface that's covered either by erosion or by deposition. Now this is a complicated figure. It shows the direction of the axis, both the erosion axis and the axis of the depositional lobe. And it's better to show this figure because it's much more simple. There's a shore normal line, and the mean direction of the erosive zone always turns counterclockwise around, on average, around 20 degrees. And then the axis of the accumulation zone also turns further counterclockwise around 25 degrees mean. And this is independent of the orientation of the coastline itself. So it is valid for the southwestern exposed coast, but also for the northerly exposed coast. Actually, one of the important things of a notch is how far its influence reaches inland, and therefore you need to calculate the distance perpendicular to the coastline. And this appears to be dependent on a couple of parameters, and I'll show you some. For example, the coastal orientation. If the coast is more oriented to the north, so northerly exposed coast, then a lot of the onshore of the southwesterly winds are not onshore, and the southwesterly winds are an important factor in the windrows. So the amount of onshore winds in the northerly exposed coast is much less than on the westerly and southwesterly exposed coast. And you can see that the accumulation zone, or the width of the accumulation zone, is also smaller in the northerly exposed coast than in the westerly or southwesterly exposed coast. Well, there's a lot of scatter. Then the width of the opening of the notch is also of influence on the width of the accumulation zone. The wider the opening is, the further the accumulation zone extends seaward, landward. And finally, there's also a very vague positive correlation between the foredune height, so the original height of the foredune where the notch developed, and the accumulation zone. The higher the foredune is, the larger or the wider the accumulation zone becomes. Now, finally, there are some indications that the sand balance in notches is more positive than in an adjacent reference foredune without notches. So it looks like notches attract sand, and that we can, however, not prove this yet, because well, the data are very diffuse, and I think this is an important point for further research. And finally, the relationship with embryonic dunes is very complex and unclear. I showed an example of the notch on Texel that stabilized due to the development of embryonic dunes, but there are also examples of very well-performing notches that also have embryonic dunes in front of them. So also this is a point of further research, and I think that's what we will be pointing at in our research the coming month. That was the story of notches in the Netherlands. Thank you for your attention.
Brilliant. Thank you so much, Bas.